Hello and welcome back to the second part of our Unit 3 lesson number 5 for MCF3MI. This is word problems for solving quadratic equations. So in our first example, we got introduced to the style of word problem we'll be doing in this lesson and in this unit. They are rectangular problems where we're asked to find the area, or I guess where we're utilizing area to find the width of a uniform sort of border or pathway or something around the outside, like a frame maybe, something around a rectangular shape. So let's jump right into example number 2, and let's try to remember the things that we were doing in the first example as a way of informing what we're going to do next. Try to make some predictions if you can. A garden measuring 12 meters by 16 meters is to have a pedestrian pathway installed all around it, increasing the total area to 285 square meters. What will be the width of the pathway? So we let A represent the total area of the garden, meters squared. Again, that's an important distinction. We're talking total area, not just the garden, but the garden and pathway together. And let X represent the width of the pathway in meters. As before, I think that the diagram really helps inform what we're doing. So there's our diagram, there's the garden, there's the pathway around the outside. In order to calculate the area of this entire shape, it's rectangle, so it'll be length times width, but we have to find out what the length actually is. So if we consider this side length, we know it's 16, at least in part, but then we have this x up here and this x up here, so that the width of this entire side would be 16 plus 2 x's. We're going to employ that same style of thinking here for the bottom. We need to know the width here. 12, obviously the part of the garden, but then we have an x here and an x here. So combined, the width would be 12 plus 2 x's. And now we have the dimensions of this combined garden and pathway. And now we can calculate the area, because that's the length and the width. So the area, that'll be the length times the width. Length times width. And the length, as we know, was 16 plus 2 x's. And the width was 12 plus 2 x's. And they tell us in the question, and this is something now, once you kind of get this part of the setup, remembering that you have an area to put in here provided in the question. It told us that by adding the pathway, the combined area of the garden and pathway would come out to 285 meters squared. So we have the beginnings of our equation. Now we need to expand it out and get all of the terms onto the same side. So again, I'm expanding like last time using my FOIL. So let's write it out. We've got 285 equals 16 times 12. It's going to give us 192 plus 32 x's plus 24 x's plus 4x squared. So next step, I'm going to combine all of my like terms, and I'm going to transpose 285 to the other side of the equation by subtracting 285. That will get all the terms on the same side for us. So let's do that. We have 0 equals, and I'm going to write these now also in that same step in the proper order by degree. So that's 4x squared plus 56x, and we have 192 minus 285 gives us negative 93. So unlike last time, we can try to factor this, but just to save a little bit of time, this is not going to be factorable. This is going to be something that we need to use the quadratic formula for. So in order to do that, we need to get the quadratic formula happening. So just as a recap, we have our A value, our B value, and our C value. Each of them important. Each of them remembering that the sign is important as well. So I've sort of set up a quadratic formula over here on the far side. You can do the same. So the first thing I'm going to do is I'm not going to bother with a rewrite of the quadratic formula. I'm just going to substitute my values in directly. So we have our negative b plus or minus the square root of b squared minus 4 times A times C all over 2A. I'm just going to double check that I remembered all those numbers correctly and did the correct substitutions. Yep, that looks good. I negative B plus minus the square root of B squared minus 4AC. Looks awesome, over 2A. Okay, so now we're going to work this through. And I'm a fan of doing it in as few steps as possible. So I'm going to type into my calculator this whole mess under the radical sign. So I'm going to hit up 56 squared minus 4 times negative 93. And that's going to equal 4,624 all over 8. And I do want to point out, if you're doing this longhand, this is, as I say a few times, a common place for mistakes are these two negatives here. I will be adding the product of 4 and 93 to the product of 56 squared. So this is what I've come up with. I've now got two different answers to go after. The first scenario will be where x is equal to negative 56 added to root 4,624 all over 8. That's our first scenario. Second scenario is going to be negative 56. Nope, I'm out of space here. Let me move this mess over a little bit. Negative 56 minus root 4,624 all over 8. So I'm going to put these into my calculator. Again, I encourage you to remember we want to finish our numerator before we divide by 8. That's what this demands. So you can do this in a couple of ways. You can do this by putting brackets around your numerators, or you can do it by hitting a hard equal when you're done your numerator and then divide by 8 and a second equal. I'm not fussy about how you do it, but you'll be getting right answers if you do it that way, and you'll be getting wrong answers if you don't. All right, let's give her a try here. So we've got negative 56 plus square root of 4,624 equals, divided by 8 equals 1.5 is the answer I have here. And let's run the second side as well. Negative 56 minus the square root of 4,624 equals, divided by 8 equals negative 15.5. So, like the other question, we've arrived at our two solutions. One of them is not applicable here, and the word we use for it is inadmissible, meaning that it is not relevant for this question. This is our inadmissible solution, and it's inadmissible for the same reason it was inadmissible in the first question, that if we're talking about the width of a pathway around the outside of a garden, you can't have it be negative 15.5 meters. So our answer is in fact going to be 1.5 meters, and we need a little therefore statement. Therefore, the width of the path is 1.5 meters. And there is our solution. Again, we're closing in on 10 minutes here. I'm just too chatty to get these things any smaller, apparently. So I'm going to stop this video now, and I'll do a final video for example number 3. Now, example number 3 is a bit of a curveball. There's a small deviation from the way we've done the first two. In principle, it's the same. One of the first steps, however, is a little bit different. So by all means, check that one out as well. Good luck.